Morning, my dear friends. Welcome back to my YouTube channel. Today I am going to solve Leetcode March 14th problem. Problem is maximum candies allocated to K children. It is medium level problem and it is bit light hard to understand. Let us see problem statement. I will make it easy. First of all, we go through the problem statement, what they have given, and let's understand how to approach to this problem. Based on this problem, similarly, we have lots of problem in Leetcode. If you see this problem, the other problems, I will give a list of problems to solve based on today's problem. Let's see, you are given a 0 indexed integer array of candies. Each element in the array denotes a pile of candles of size candies of I. That means they have given an array called candies. Each element in the candies, for suppose example 5, 8, 6 is an example. Each element in the candies denotes the size of the candies. Each element denotes the size of the candies. So here they have given 5. That means it can store candies of size 5. It can store candies of size 8. It can store candies of size 6. Here you can divide each pile into number of subpiles. That means this each pile 5 we can divide into number of subpiles. Let's suppose 5 number of ones, or 1 2 1 3 1 3 1 2, or 1 4, and so on. Like this we can divide into number of subpiles. But we cannot merge two piles together. But we should not merge these two elements. It is wrong. Now what we have to do? You are given an integer k. You should allocate piles to candies to k. Children must have such children. We should divide these candies to the children's that each children gets the same number of candies. Each child can be allocated candies from one only pile. That means each pile, all the students, suppose k is equal to 3, all the students should get same number of piles. And each student should get from only one pile. If it is we are giving this from this 5, if we are giving 3, from this pile also you should give 3 only. From this file also you should give 3. What is the maximum value of this? What is the maximum value of this? We give to children. What is the maximum value of the pile? We give to the children. Let's see how to solve this problem. At last they have said that we should return the maximum number of candies each child can get. Let's see an example and go through the example. Here I have went through examples. I have went to solve this problem through examples only. Let's see how this example are useful to solve this problem. Let's suppose candies is denoted with C and K is equal to 3. Here if I give each child of 3 piles each, from this you can get 3, one number of pile. From this pile you can get 2 number of piles. From this piles you can get maximum number of 3. Here if we keep result as a variable, initialize it with 0, from the number of piles you can divide is 5. But the value is 3. Now if we divide the each pile into 5 each, from this pile you can get all the candies. For this pile you get only one number of. For this file you can get one number of candies only. Here result is equal to 3, but we can get a maximum of 5. Here we should know one thing, that so my dear friends, we have seen that it, we can divide the elements of 5 elements, 5 piles. Let's see another example, in which example 2 states that the candies of 2, 5 and number of students are 11. If we sum these elements, it would become 7 and the number of students are 11. Giving the candies of 7, we have 7, we should give to 11, which is 11 students, which is not possible. So we return 0. First, initially, approach. How can we approach to this problem? Approach is, initially we should count the sum of the elements, sum of these elements. Let's take an example of 5, 8, 6 candies of size, and k is 3. K is 3 candies of 5, 8, 6. Now we calculate the count. We calculate the sum of these elements in a candy. That is 5, 8 is 13, 13 plus 6, 19. If the sum is less than or equal to k, then we return 0. If it is greater than, we calculate the solution. That is the possible. Here we contain a possible solution. Here, for this sum, for this each element, we should go through the approach of, for every element we should divide 1, 2, 3 up to candies of I. For each element candies of I. Let's suppose this takes a time complexity of q and number of elements is n. The total time complexity is equal to O of n into q. That is nearly equal to O of n square, which is high. We should optimize this solution. Understand, my dear friends, why I have chosen this brute force. First we have gone through the brute force, because for every element of I, we should calculate the number of element of subdividing. It is possible ways are q number of possible ways. So the time complexity leads to O of n square. Now what is the optimal approach? Optimal approach is, for 0 to n, 0, 1 to n number of elements, we calculate the mid value. Calculation of mid value. We are dividing and conquering. Dividing the array into subarrays and calculating the solution. Calculating of mid value. First condition is calculating the mid value, and second condition is these elements are in increasing order. By knowing these two conditions, we should know one approach. That approach is binary search approach. By listening these two conditions, we should get one approach, that is binary search approach. From 0 to n, instead of calculating from 0 to n, if we calculate from 1, that means left. 1 means, because we have chosen 1 because each student should get minimum of 1. And what would be the maximum? Maximum of sum of those elements divided by k. This will be that means minimum 1, 2, 3, 4, 5, 6. For this example, minimum of 1. each student should get minimum of 1, minimum, and maximum of sum divided by k. The student should get minimum of one element and maximum of sum divided by k elements. Now let us see how this binary search is useful for this. What is the initial condition? While left, calculate this minimum or assume it as left, maximum or assume it as right. While left is less than or equal to right, when left should be less than or equal to right value. Left should be less than or equal to right value. While left, it is the condition for the binary search. We should calculate the mid value and we should know the conditions. That means when to divide the array and when to increment the array. That means when to decrement the right and when to increment the left. Here, if we calculate for 3, mid value is equal to left plus right by 2. Left plus right by 2. Mid is left plus right by 2. Here we get 1 plus 6 divided by 2 is 3. 7, that we store it in the form of integer. We get mid as 3. Now, if we calculate this mid value, we have calculated this mid value. This will be the maximum value. This will be the maximum value. If this maximum value is greater than or equal to k, if this maximum value is greater than or equal to k, that means we have got the maximum number, still the maximum is existed. Still the maximum is existed in this range. So we increment the left plus 1. Left is equal to mid plus 1. Mid plus 1. If else, if this is the condition 1, else right is equal to mid minus 1. Right is equal to mid minus 1. This is the condition. When do we go through this approach is, this is the main condition for which decrementing of the value and incrementing of the value. When to decrement the value and increment the value. When we calculate the number of child counts, that is, child counts is number of possible values. Is greater than or equal to, that means still the maximum is existed. Still the maximum number is existed. We calculate in this range. No, the value doesn't in the range. We calculate in this range. So these are the conditions. And for when the left is less than or equal to right, we iterate through the array elements and we calculate the child count. Let us see problem solution. Initially, we keep an integer of some 0. We calculate this for example 5, 8, 6 and k is equal to 3. 5, 8, 6 and k is equal to 3. We initially calculate the sum. Sum is 19. Left is equal to 0. Right is equal to, sum is 19 divided by 3, that is equal to 6. We imagine as array or elements, that is from 1 to 6. 1, 2, 3, 4, 5, 6. We initiate this array. Calculate the result. We keep a track of the result, initialize with 0. This is left element, this is right element. Left is less than or equal to right. We calculate the mid element. Mid is this. We check if we divide the each candy by 3, we calculate the value. child count. We keep it in the child count. That is, for 586, we divide each element into 3. Maximum of 3. That means remaining is 2. Here the possible ways are 3, 3 and 2. Here the possible ways are 3, 3. Number of values, that is, we get number of values of 5. That is child count. Number of children they can get this maximum of 3 is 5. Let's check the condition whether the child count is greater than or equal to k. Yes, it is greater than. So we came to know that it is greater than k, and still the maximum element is existed. So we have to check for this element in this range. Left is equal to this and right is equal to this. We calculate the mid is this, mid is this, and we divide the array element into maximum of 5, 8, 6. We for this array element the maximum is 5. For this 5 and another candy size of 3. For this 5 and another kind of 3. Child count is equal to number of children you can give it. This is 1, 2, 3. For 3 number of children you can give, and the k value is 3. Here the condition is child count is greater than or equal to k. Child count is greater than or equal to k, and we keep it in the initially 3 and now it is 5. It is 5. Now still we check for the still any maximum value is existed. Now this is left. We increment left as mid plus 1. Left is less than or equal to right, or left is equal to right. We calculate the mid value. Mid value also points to this element only. Mid value also points to this element only. We calculate for each candy if there is possible way of 6 elements. If there is a possible way of 6 elements dividing. That means for this element we cannot divide. For this element we cannot divide. For this element we can divide of size of 6 and remaining candies is true. For this element we can divide 6. Here we can give only to the 2 students. If we divide the candy of size k or 6, we can give it to the 2 students only. But they have said you should give to the k number of children, which is 2 is less than or equal to k. So this is false, and we return this condition is false, and we return at last we return the result. At last result is 5. We check whether the solution is 5 or not. Here we can see the solution is 5. We have got the answer. So thank you my dear friends. I hope this solution made easier to all of them, and subscribe to my YouTube channel. And another problem using the same approach is question number 875 in Leetcode, that is cocoa bananas. Cocoa eating bananas. Cocoa eating bananas. Once try this problem. It is similar to this problem only. So thank you my dear friends. Subscribe my YouTube channel and share with your friends. Thank you.